Okay, I'm having a look at question 19 out of the 2022 tech-free paper, the maths methods. So we've got a scenario here where we've got two triangles that are said to be similar if their corresponding angles are congruent and the corresponding sides are in proportion. So we've got if UVW is similar to XYZ, then the angles U, X, V, Y, so that the U is going to be equal to angle X, the angle V is going to be equal to angle Y, and angle W is going to be equal to angle Z. So in similar triangles, the angles all match, and then their sides are in proportion. So then you can say that the side UV divided by XY is going to equal VW divided by YZ, which is UW divided by XZ. Then we've got some information that two parallel walls, AB and CD, where the northern ends are A and C respectively. So we've got two parallel walls. So we've got AB and we've got CD. So we've got A and C are the northern ends, are joined by a fence from B to C. The wall AB is 20 meters long, so we'll put that in there. And the angle ABC is 30 degrees. And the fence BC is 10 meters long. So we know the total is 10 meters. Then a new fence is being built from A to a point P somewhere along that line CD. So somewhere along here, we don't know where, we're putting in a new fence. And the new fence AP will cross the original fence BC at O. So we're putting an O there. And so it says let OB be equal to X. Now if we know the total is 10, then this section here must be 10 take X. And we want to determine the value of X that minimizes the total area enclosed by OBA and OCP, and verifying that that's a minimum. So what we're going to use here is that these are similar triangles. So the bit at the top was a little bit of a hint that that was what it was going to be about. Now we know that these two angles would have to be equal because they are opposite angles, and then if these are parallel lines, we know that this angle here would have to equal this one up here. So we can put that in. And then we would also know that these two angles are equal there as well because of the Z rule again. So we have that bit of information there. And we're looking at the areas. So we want the total area between the two triangles. So we can start putting a bit of information into our rule here. So when we have our total area, we can use, because they're non-right angle triangles, we can use that rule area equals a half AB sine C. So if we've got that sine C here, we're wanting these two sides. So for this first triangle, the ABO, we would have a half, and it's a half AB sine C, so a half times 20 times X sine 30. And we would be adding to that the other triangle, which would be a half and the A and the B. So here's our 30 here, so the A and the B would be those sides. So we've got a half times, and we don't know this length, so we're just going to call it CP. We could put in a letter if we wanted, times, and then we've got the 10 minus X, and we have the sine 30 there. Now this is a tech-free question. We know that sine 30 is equal to a half. So we can do a half times 20 times X, and that would be times a half, plus a half times CP times 10 minus X times a half. So we get a half times a half is a quarter times 20 is 5X, plus we've got a half is a quarter, CP outside of 10 minus X. Now the other thing that we can use is this information up here about the sides being proportional. So if we've got CP there, we can divide it by our length AB to get that ratio between the two triangles. So we know that ratio CP over 20 must equal when we do the 10 minus x over x, which means we can then get an expression for CP that just has x in it. So we've got CP is going to equal, and we'll bring that 20 over, and we will get 20 outside of 10 minus x over x. So now we can put that in where we see the CP there. So we can bring that total area. We've got the 5x, and we're going to have that 1/4 times the 20 outside of 10 minus x over x, and we're multiplying that by 10 minus x there. So we've got the two brackets that have 10 minus x in, so we can make that 10 minus x squared. We've got the 5 and the 20 and then 1/4. So that would then, when we are multiplying that out, we should get the 5x doesn't go with that, and I want to put that together. So the 5x there, so I've got the 1/4 times the 20, so that's going to have the 5. And we've got that x on the bottom, so we need to keep that x there as well. So simplifying that, we will get the 5x plus our 5 outside of 10 minus x, it's all squared over x, or we could write this also as 5 over x and then multiplying by 10 minus x squared plus 5x. So now we have our total area. Our next step is to then find out, because we wanted it to be a minimum. So to identify if it's a minimum, we're going to need to find the derivative of that. So we want the TA dash. So we want to then do the derivative. Now looking at that, we might just do a little bit of simplifying to help us find that derivative there. So we've got our so we've got the 5x. We might bring that all over our x to make that a little bit easier and expanding out that bracket. So when we've got that 10 minus x squared, that's going to give us our 100 minus 20x plus x squared. Then we want to multiply through by 5 over x there, so we've got plus 500 on x minus 100x over x plus 5x squared on x. And then we can simplify that. We've got this 5x here. If we write that as 5x squared over x, then we can bring it together and put them all over x to make it a little bit more simplified. We can bring them all together over the x. So then we have 5x squared plus 500 minus 100x plus 5x squared, which we can then bring together and say we've got our 5x squared plus our 5x squared is 10x squared plus 500 minus 100x over x. And then we want to differentiate that. So what we can do then is now we can separate it back out. And so we've got 10x squared over x will just give us 10x. I'm going to write that as 500x to the negative 1, and then that will be minus 100 there. So that's my area. So then my area dash will just be 10 plus negative 500x to the negative 2, and that will be take 0. So then I can write 10 take 500 on x squared. And then if it's a minimum, that's when that is equal to 0. So we can write 0 is equal to 10 minus 500 on x squared. We can bring that over to the other side, bring that up here. So we've got 500 on x squared is equal to 10, multiply through by x squared. 10x squared is equal to 500. divide by 10, we get 50 is equal to x squared. So our x is equal to the square root of 50. Now when we do the square root, that's going to be plus or minus. Now we've got our x is our value for the length of that line. So we can't have a negative, which means it's just going to be the square root of 50. Now to test if that's a minimum, we want to then do the double derivative to test that in and check what that's equal to. So that means we're going to have to then find the derivative of our a dash there. So the 10 is going to go away. That will be, so we're finding, so I'll rewrite it, 500x to the negative 2. So that means that we would have our a double dash, we would bring down that, so that would be positive 1000x to the negative 3, which is 1000 over x cubed. Now we want to put in the square root of 50 there to check that. And so when we put that in there, we can check that it's greater than 0, and then that would mean that it is a minimum. And we can verify that it is the total area is minimized for that. Hopefully that helps you with that question.